afternoon, viewers. I'm Mr. Eko Jeremiah, and I'm here to demonstrate how chemical energy can be converted to electrical energy using the normal salt, which is sodium chloride, the table salt, and tomatoes. This principle actually was discovered by Alexander Volta in 1793. He found out that when different metals, this copper and this zinc, are placed at opposite side of a wet cloth or an ionic solution, there's flow of electron. So here the experimental procedure, you get your normal salt, which is sodium chloride, you get a copper metal and a zinc metal. The zinc acts as the anode, is the site where oxidation takes place, while the copper acts as the cathode, the site where induction takes place. Okay, you know that water initially normally is an insulator, that means it doesn't conduct electricity, but when salt is dissolved in it, the water pulls the sodium and chlorine molecules apart, ionizing it. Okay, so we have a sodium ion and chlorine ion, which are the mobile ions in the solution. Okay, they are free moving, and immediately the circuit is complete, the ions in it flow from the zinc metal to the copper metal, that's from the anode to the cathode. Just watch and enjoy yourself. First, you fill your bowl with water. Water here, so fill with water, and then you add your salt to it. Okay, so I have scissors here, and you stir continuously to ensure that the salt dissolves properly. After that, you fill in your beakers. Okay, we call them cell, and you can also call it the voltaic cell or the galvanic cell. So just watch me as I fill my beakers, also my cell with this water. Then fill to three-quarter of it. Okay, yeah, perfect. So now you connect your electrodes, and when you're connecting it, you make sure that you don't have two same metal, like copper in one cell or one beaker. So here I have my copper and zinc. Okay, likewise this one, copper and zinc. So you have copper and zinc. You have copper and zinc. There, sir. You have copper and zinc. And you observe that immediately you place this one, there's a bulb. Okay, the circuit is complete. Electrons will flow and it will light up the bulb. Okay, wow, this looks beautiful, don't it? As you have that bulb here, you can also use this one. If you use this one, it's a green bulb. It looks beautiful. And also you can also measure out you see as I stir, it goes brighter. You can also measure out the voltage using a voltmeter. Okay, and you can see it's going almost to the 3 mark there. And with this, because sodium chloride is a strong electrolyte, it ionizes completely in water. Alright, this principle can also be demonstrated using tomatoes, because tomatoes is acidic, and acidic substance, they also conduct electricity. Sodium tomatoes here contain oxalic acid, and oxalic acid is a weak acid, but still it will conduct electricity, but not as bright as the one we have with our salt here. So I'll do that same connection here, and you watch how it will light up the bulb. Okay, so you may want to raise this so that you don't feel it's the sodium in it that is conducting it. So you want to raise it so that you see what is really going on here. Okay, make sure you have different metal. Here I go with my bulb. See, it's gonna come up now. Wow, you can see it, but not as very bright as we have with our salt water, because the oxalic acid is a weak acid, okay, a covalent compound, unlike the sodium chloride, which is a very strong acid. I want to try it with this other bulb so you see how it goes also. Wow, you can see it looking beautiful. And you can also measure out the voltage using a voltmeter. If I should connect the voltmeter now to it, you will find out that it will indicate a flow of electron, but you see it's not very high as compared to the salt water, okay, because the acid contained in tomato, the oxalic acid, is a weak acid. I hope you enjoyed this. Please like my video, comment and subscribe. Thank you.